Hello students, hello everyone, welcome to the chemistry grade 12 lesson. On the previous class we have seen about the meaning of the term solution and its classification, and we have said that solution is a homogeneous mixture of two components, these are the solid and the solvent. Solid is a substance that gets dissolved, and whereas the solvent is a substance that does dissolving. Or we can also define these two components as a major component and a minor component. Solid is a minor component and solvent is a major component. And the other thing that you have seen on the previous class is about the classification of solutions. So we have said that we can classify solutions into three classes. These are the gaseous solution, the liquid solution, as well as the solid solution. Okay, this is what you have seen on the previous class. Today we will try to see about two things. And the first one, we will try to see about the solution of process. The solution process. When you say a solution process, it is a process that tells us how a solution is formed. And the other thing is, we will try to see about the principle known as like dissolves like. Okay, like dissolves like. So, came to our lesson. The solution process. You know that on the previous class we have said that a solution can be formed from its two components, a solid and a solvent. Solid combined together with a solvent to produce a solution. But this process could not occur in a single step. It follows a series of steps. Okay? Therefore, always a combination of solid and solvent form a solution could not occur in a single step. So it involves three distinct steps. So the solution process occurs in three steps. The first one is, you know that the solvent particles are combined together by strong intermolecular forces. So the first thing is the solvent particles must separate from each other. This is the first step, solvent separation. You know that if you consider water as a solvent, water molecules are combined together by strong hydrogen bond. So, to produce a solution by using a water solvent, these water molecules must first separate. This is the first step, solvent separation. The intermolecular force that holds solvent molecules together could be first broken down or weakened. Okay? Therefore, this is the first step. Since this step involves bond breaking, it is an endothermic step. The process is endothermic. Okay? It requires energy, external energy. And the second step is the solid separation. The solid separation. Second step is solid separation. For example, if you consider ammonia as a solid or hydrogen chloride gas as a solid, you know that hydrogen chloride is a polar molecule. Therefore, there is an intermolecular force that the solid particles combine together. So, to produce a solution by combining with the solvent, the intermolecular force that holds the solid particles together must be weakened or must be broken. This is also an endothermic process. Because it requires energy. Since the process is bond breaking, so it requires energy. That's why we have said that the process is endothermic. And the third step is known as solivation. or hydration. This process occurs after the solvent particles separate together and after the solid particles separate together. So, solvation or hydration will occur. When you say solvation or hydration, it is a process by which a solid forms an interaction with the solvent. Okay, the solvent. The new intermolecular force will appear or will exist between the solid and the solvent in this way. So, during the solvation step or hydration step, the solid particles are being surrounded by the solvent molecules. For example, if you considered solvation is a process by which a solid particles being surrounded by a solvent molecules. This is the meaning of solvation. Okay, the term solvation will be called hydration if the solvent is only water. Okay, if our solvent is water, the process is known as hydration. So take the solution of sodium chloride salt in water. See the following figure. When sodium chloride salt is dissolved in water during the solvation or hydration stage, the water molecule will surround the particles of the solid. In this way. Okay. So the sodium ion will be surrounded by water molecule in this way, and the chloride ion will be surrounded by water molecule in this way. This process is known as solvation or hydration. Okay, solvation will be hydration if and only if the solvent is water. Okay, so solvation is a process by which a solid particles are being surrounded by the solvent molecules, and this stage is either it can be exo or endothermic. Okay, the solvation state will be either endothermic or exothermic. So in the solution process class, we have seen about the solution process will occur in 3 different steps. The first step is the solvent-solvent separation. So the solvent-solvent separation is an endothermic process, and the second step is the solid-solid separation. Then the solid-solid separation is also an endothermic process, and the last stage is solvation or hydration, which is, when you say solvation or hydration, which is a process at which an intermolecular force will exist between the solid and the solvent. Or we can easily define solvation or hydration in this way. Solvation or hydration is a process by which the solid particles are being surrounded by the solvent molecules, and this process will be either exothermic or endothermic. So students, please, this is time for an activity. Please ready to do an activity with regarding of the solution process. This is our first activity for today, activity 1. The exothermic step in the dissolution of salt in water is A, separation of salts into gaseous ions. B. Separation of water molecules. C. Hydration or solvation of the salt by water. And D. A and B are correct answers. Student, I think so, or I'm sure you had no trouble with this activity, but please do the activity together. The exothermic step in the dissolution of salt in water is the first alternative. A is separation of salts into gaseous ions, which is the solid-solid separation. Solid-solid separation is an endothermic process. And the second alternative B is separation of water molecules, which is the solvent-solvent separation. Solvent-solvent separation, which is an exothermic process. And the third one is hydration or solvation of water salts by water molecule. This is the last step, and this will be either exothermic or endothermic. And D, A and B are correct answers. Therefore, the answer will be C, exactly. If your work is just like this one, it's good work, students. Let's continue the second subtopic that we will try to discuss today. The second concept is the principle known as like dissolves like. Like dissolves like. The principle known as like dissolves like. And this principle, you know that in our first lesson we have said that a solution can be formed by dissolving the two components, solute and the solvent, but it doesn't mean we can form a solution by dissolving any solute with any solvent, okay? By dissolving any solute in any solvent. So the like dissolves like answers which solute will dissolve it in which solvent, okay? So according to this principle, according to the like dissolves like principle, two substances are miscible in each other or soluble in one another if and only if have similar intermolecular force in type and magnitude. Or for example, if you take two solids, two substances, substance A and substance B, always there is an intermolecular force that exists between the substance A, and there is also an intermolecular force that exists between the substance B. So if you want to form a solution by mixing these two components, component A and component B, according to the principle like dissolves like, the substance A could dissolve in B if the intermolecular force that exists between molecules A and molecules B are similar in both type and as well as magnitude. Okay? When you say type, you know that the intermolecular forces may be dipole-dipole or hydrogen bond or London dispersion forces. And when you say in magnitude, it refers specifically for its strength. Okay? So according to the like dissolves like principle, two substances are miscible in each other. Two substances are miscible miscible in each other if they have similar, not the same, actually, not the same, similar intermolecular force. Intermolecular force. The similarity will be in both type as well as magnitude or strength. Or we can explain the principle like dissolves like in other way. Okay? According to the like dissolves like principle, always a polar solid will dissolve. A polar solid will dissolve in a polar solvent. Or a non-polar solid will dissolve in non-polar solvent. This is a principle known as like dissolves like. Let us see an example. Let us see an example. Iodine molecule does not dissolve in water. But methanol or ethanol, alcohol, dissolves in water. So this difference, both, if you considered both iodine molecule and ethanol as a solid, iodine molecule could not form a solution by dissolving in water, whereas the methanol forms a solution by dissolving in water. So if you want to explain this one according to the like dissolves like principle, this is because the intermolecular force between the iodine molecules are London dispersion forces, which is a weak intermolecular force, whereas when it came to the water, the intermolecular force between the water molecules are strong hydrogen bond. Okay? So, this is hydrogen bond. According to the like dissolves like principle, two substances are miscible in each other if and only if they have similar intermolecular forces in both type and magnitude. When it came to here, the intermolecular force that exists between the iodine molecule is London dispersion force. So it's very weak force. Whereas the intermolecular force between water molecule is hydrogen. So hydrogen is a strong dipole-dipole interaction. Therefore, the two substances are not miscible. They are not miscible according to whom? According to the principle known as like dissolves like. And when it came to the second example, which is a solution made by dissolving ethanol in water, you know that the intermolecular force between the ethanol molecules are hydrogen bond. And when you say hydrogen bond, students, you know that hydrogen bond exists when the element hydrogen will act as a bridge between the three most electronegative elements such as oxygen, fluorine, as well as nitrogen. Okay? So the intermolecular force between the ethanol molecules are hydrogen bond, and the intermolecular force that exists between the water molecules are also hydrogen bond. Okay? Hydrogen bond. Therefore, according to the like dissolves like principle, ethanol will dissolve in water to form a solution. Why? Because their intermolecular force is similar in both type and magnitude. It's time to do more one additional activity, which is activity 2. Which one of the following gases, which one of the following gases should have a significant solubility in water? Should have a significant solubility in water. Okay. A, nitrogen gas, and B, hydrogen chloride gas, C, oxygen gas, and D, hydrogen cyanide, and A, ammonia. Please, student, try to finish your work with a given time. You have 1 minute to do this activity. Welcome, students, again. Please do the activities together. You know that water is a polar molecule. So in water molecule, the intermolecular force that exists is hydrogen bond. So according to the like dissolves like principle, we have said that according to this principle, one substance is miscible in other substance if they have similar intermolecular force in both type and magnitude. So if you consider the alternatives, when it came to nitrogen for case A, nitrogen is a non-polar molecule. So the intermolecular force that exists between non-polar molecules are always London dispersion force. And when it came to the HCl is hydrogen chloride gas, is a polar molecule. So the intermolecular force that exists between this polar molecule is dipole-dipole interaction. Okay. And when it came to the oxygen is a non-polar molecule. The intermolecular force that exists between the oxygen molecule is always weak London dispersion force. And when it came to the hydrogen cyanide is a non-polar molecule. So the intermolecular force that exists between the non-polar molecule is always London force. Then the last one is the ammonia. Ammonia is a polar molecule, therefore the intermolecular force that exists between the ammonia molecules are hydrogen bonds, because the element hydrogen acts as a bridge between the most electronegative elements, nitrogen. Therefore, for this question, since our solvent water is a polar molecule, nitrogen molecule could not dissolve on it, and oxygen molecule could not dissolve in water, and that of hydrogen cyanide could not dissolve in water. So we do have two solids, HCl and ammonia. Okay. So when you consider HCl and ammonia, both are polar molecules, but the intermolecular force that exists between the ammonia molecule is similar with that of water, exactly the same. Because the intermolecular force that exists between the water molecule is hydrogen bond, and also the intermolecular force that exists between ammonia molecules are hydrogen bond. Therefore, of this gases given here, ammonia has a significant solubility in water according to the principle known as like dissolves like. Okay. So students, today we have seen about two things. In the first case, we have seen about the solution process, we have said that a solution process is not a single step. So a solution occurs or formed by 3 steps. In the first step, the solid particles must be separated. In the second step, the solvent particles must be separated. And lastly, a solution is formed when the solid particles are being surrounded by the solvent molecules. This is what you have seen on the solution process. And the last thing is, we have seen about the principle known as like dissolves like. So according to this principle, always a polar solid is dissolved in polar solvent, as well as a polar solid is dissolved in a non-polar solid is dissolved in non-polar solvent. This is what you have seen on today's lesson. Students, this is all the time given for today. So until the next time, thank you, students.